Good morning to all of you. So, in Coelenterates, we have already discussed about the general characters, classification, and the example in the respective classes. Today, in continuation of that, we will discuss a little more about the coral reefs because coral reefs are the very interesting as well as very relevant coelenterates, especially in the oceans. So that's why we can discuss about these coral reefs and know something more about the coral reefs. So these coral reefs are built from the remains of stony corals. Actually, there are two types of coral. One is soft corals and other one is the hard corals. Soft corals will not build the coral reefs, but it is the stony corals or the hard corals. These coral reefs are considered as the rainforests of the ocean for the very simple reason that in the rainforest you can expect the primary maximum primary productivity as well as the ecological contribution of the rainforest on the land or in the terrestrial habitat is remarkable. The same purpose is carried by these uh, corals in the ocean. So that's why these corals are called as the rainforests of ocean. So these reefs, coral reefs, the big colony of these corals, we call it as reefs. They are about 1 lakh square miles of the world's shallow marine areas. Mostly we will find these coral reefs in a shallow water and that too more in the tropical water or in the warm water. These coral reefs they grow very slowly, gradually. Uh, when the organisms living on the surface multiply, spread, and die. Even when they die, they leave the coral shells there only, adding their limestone skeleton. Most of these hard corals, or what you call stony corals, they are made up of the limestones. So, uh, hard materials they leave that and helps in building the coral reef. Basically, there are three different types of reefs, and even two more classification is also possible. The basic coral reef classification scheme was first proposed by Charles Darwin. Even Charles Darwin has observed that, and based on that, he has three main types: fringing reefs, barrier reefs, and atolls. Whereas nowadays two more are added and they are called as patch reefs and bank reefs. First, let's try to understand what is the fringing reef. So, this fringing reef they are adjacent to the land where they are not separated in many times, though they are found in the ocean, but they are not separated from the shore. They are continuous from the shore. So, such reefs are called as the fringing reefs. Usually it helps or they grow or develop upward by the growth of reef forming corals. They start at the base like this and there will be an uphill development process. And especially all these are very close to the shore uh, on the area what you call the continental shelf. Continental shelf is the shallow marine area very close to the shore. In some places, there may be completely shallow lagoons in some area or no lagoons at all in between them. The most common fringing reefs you can expect in the Caribbean and Red Sea. They are the greater Caribbean reefs as well as the Red Sea reefs are most of them are these fringing reefs. They are also surrounded by many South Pacific and Indian Ocean islands. Uh, Nowadays, these coral reefs have become very susceptible because of the whatever the development that takes place in the coral in the coastal zone, because they are very close to coastal region, agriculture, pollution, and even the human activities, where lot of sediments uh, enter into this area, and as a result, many of these uh, fringing reefs are uh, facing a very precarious future. The next one is the barrier reef. Here, they are also very close to the shore, but the thing is, they are separated from the land by a lagoon. There's a water channel, which can be lagoons can be as wide as 1 mile, 1.5 miles also, and even some few yards deep also. They run usually parallel to the shore. In the photograph, you can see they run usually parallel to the shore, and in between that there's a lagoon. And even here, the they develop this coral structure often protrude above the sea level, but not like a mountain as you have seen in case of the earlier photograph. Here they are more flat, and this develops as the wave action. Most of these barrier reefs are developed because when the wave brings the coral segments broken off from the reef itself and put it there, and as a result, it will be like a embankment. Largest reefs develop on the edges of the continental shelf. So that's why many times it is also called as shelf barrier reef. A good example, which all of you might have heard, Great Barrier Reef in Australia, or Belize Barrier Reef. So these are the good example for barrier reefs. Next one is the atoll. Atolls look like a compound wall that has been built to a well. These are large ring-shaped reefs surrounded by a central lagoon. Lagoon is in the center, see. Surrounding that, there are the reefs. These are not very close to shore. They are well away from the large land masses, which are generally you can see in the South Pacific Ocean. Usually circular, or mostly they are horseshoe shaped structures. And even part of the atoll may protrude out like this, out of the water, and forming the coral island. They are called as atolls. They are most common in the Indo-Pacific region. There are over 300 such geese are there. But they are very rare in Caribbean, only 10, 15. Uh, some of these atolls can exceed 100 miles in diameter. Even the central lagoon, the lagoon which is found in the center, can be several thousand square miles also. Such a big atolls are also possible. Then the patch reef. The photograph itself shows you how it appears. Small reef. They are found within the lagoons of the other reefs. Wherever there's a lagoon, there's a water body. Um, they are found within the lagoons of other reefs also. Usually small and isolated outcrops. See, like this. Small isolated outcrops surrounded by sand or seagrasses. But ecologically, these are also very important because they provide shelter and space and food also for many species of the animals and fishes. Then the bank reefs. These bank reefs, these are the structures with no link with the coastline. They are totally separate in the ocean. You can see it looks like a wall bed. So like this, and they are called as the bank reefs. They have no connection with the coastal line. They are far away. Generally, they are far away from the coastal line. Now, how these three main reefs might have evolved? Actually, the reefs were first observed and proposed by Charles Darwin. Darwin, what he has suggested, these three main reefs are simply different stages of geological evolution. He said that it in there these three different types of lagoons are in the different stages of evolution, geological evolution of the Pacific oceanic islands. Uh, as per the Darwin's theory, the fringing reefs they grow near the shoreline of new island. Mostly these fringing reefs they began close to the shoreline in a new island when conditions for growth are ideal. When a new island is formed in the coastal line of those islands, this in the shoreline, the fringing reefs begins to grow. Then, as the island slowly subsides into the sea, but the corals grow at the same rate and remain in a place at sea surface, which are further from the shore. They are called as barrier reef. He says that when the fringing reefs gradually subsides in the sea, sometimes it happens in the ocean, but the corals are able to grow and there will be fringing reef like this. And now that is called as the barrier reef. Eventually, when even the barrier reef also disappears below the sea surface, leaving only a ring of corals surrounding it, that is what we call atoll. So that's why Darwin suggested that these three types of corals, the fringing reef, barrier reef, and atoll, they are at the successive stages of geological evolution. Fringing reef is the first condition, then it becomes barrier reef, and lately it becomes the atolls. That's what Darwin has said. Darwin's theory of this reef evolution was verified in 1950s by the Indo-Pacific reefs by deep core drilling of Bikini and Enmetok atolls. They know that now we know that. However, what Darwin has proposed is not true. The three types of these reefs can be formed by different process. It need not be in different stages of geological evolution, but it can be because of number of other factors also. Now the question is how the reef formation takes place. When millions of hard coral polyps in the marine region are responsible for building these hundreds of coral reefs now which you observe in the ocean. Actually, these reefs are nothing but the excretion of calcium carbonate produced by the polyp of the coelenterates. The polyps excrete this calcium carbonate and that gets deposited there. Usually, new polyps secrete the calcium carbonate on the top of the older polyps. As a result, there will be reef formation. The growth of the reefs, if you observe, they show these three basic growth forms: massive, branching, or plate-like. See, these rely on shear mass growing into a huge sheet or boulder formation, as you can observe in the photograph. And this um, make make up the bulk of the reef. Bulk of the reef is massive, and it is because of massive growth. Then, uh, even the branching, because only massive growth cannot sustain the big coral reefs. It requires small area to anchor themselves, attach themselves, or firmly hooked with something. Uh, so this, for that matter, they branch out into vast tree-like colonies. Sometimes they may be plate-like, they flat expanses. These flat expanses, in most of the time, overshadow the other corals, and they only monopolize whatever the light that is made available. See, these are the plate-like growth. The corals which are below that will not receive sunlight. Some corals they grow very slowly, but some can grow up to few inches in a year. Now, coming to the structure of the coral, all corals, most of the corals are symbionts. They contain the photosynthetic organism which live in the tissues of the coral polyp. And the tissues of these coral polyps provide food to these polyps. Because of the coloration of this algae, the corals also get the color from those. But remember, the corals to grow, it needs sunlight. So that's why the corals are seen in the shallow water. Because in the deep water, the light will not penetrate. Certainly, the light can penetrate in the shallow water. So this is a very interesting association that is seen corals and photosynthetic algae, especially zooxanthella. The entire coral reefs are not built by the corals only, because there are some molluscans and echinoderms which also secrete the calcareous shell. They also add their calcareous shell to this coral reefs. And sometimes it has also been seen grazing or boring organisms. They break down the coral skeleton into fine sand. Even there are some algae which bind to the sand, especially the coralline algae. These are the reasons where one can see the maximum corals. Here only you can see the maximum corals are found in the tropical region. Next, how the reefs are distributed. Almost all these coral reefs are, they can grow in a clear, clean, sunlit water. There must be sun rays reaching them, and for that matter, the water should be very clear so that sun rays can reach the deeper depths. Average salinity should be around 36 ppm. Mostly it should be warm water, and the wave action should be limited. If it is there is no wave action is well more good. One such area is Indo-Pacific region. Greatest numbers are in the area of southern Philippines. Through the New Guinea and Indonesia, you can see that. This is the Greater Caribbean region. Entire Caribbean Sea, Bahamas and South Florida. Here also you can see this coral reefs. The parts of the reef, if you see, this is the open sea, outer margin crust, reef crust, and back reef. These are the parts, we need not go to that. Reef slopes are the narrowest of the reef zones. So that's why all coral islands show some slopes, what we call reef slope. Reef flats and lagoons are also there, where they contain shallow water habitat for reef species. These corals are very susceptible to environmental changes. Even change in the temperature, salinity change, even the circulation of the water if it is affected, and sediments or silts accumulation will affect the reef building process. Now the question is why these reefs are important to human beings. One thing, as I have told you, they create a very large living biomass than any other marine ecosystem. More living biomass is seen in the coral reefs. Naturally, the coral reefs contribute to local economy because a lot of people come to see the coral reefs. And the coral reefs are one such area which support more species, more marine species than any other marine environment. Even there are possibilities of these corals in medicine and science. More importantly, the corals control the CO2 level, carbon dioxide level in the ocean water. The coral polyps can turn carbon dioxide in the water into the limestone shells, calcareous shells. These coral reefs occupy only 2% of the ocean's area, but they are the home to one-fourth of all known marine species. 25% of the marine species are found in the coral reefs, but coral reefs are occupy only 2% of the ocean. But unfortunately, today, about 10% of all the reefs have been already destroyed. There are a lot of threats, mild, moderate, heavy, like that. The corals are considered as biological indicators of pollution. If there's a slightest pollution in the ocean water, if you see, it will affect the coral family, coral group. So that's why they are the indicators of pollution. More the pollution, less will be the corals. The human beings have affected these coral reefs, especially when there's a oil leakage, pesticides, chemicals, heavy metals, garbage. Then that affect the quality of water and then even the corals also. Other factors include the uncontrolled development of the coasts. There's uncontrolled development in the coastal region because in the coastal region density is also high, land mass available is less. So that's why. Then deforestation also affects whatever the coastal development we say, building hotels, homes, harbors, that also affects the corals. Sometimes the recreation activity, a lot of people go to observe these beautiful colored corals. Many times the boat anchors, when they put it crash and got the reef. The corals are the important destination for any tourist. People go underwater using the snorkelings and snorkels and uh, observe these coral reefs. Then many people collect the corals and organisms because it has lot of ornamental value and very costly also. There is market for everything from the coral, especially in the shells, sponges, even the reef animals in jewelry and sculptures. So these coral skeletons are sold as live rock. Why they are called as live rock? These are popular in aquarium because there's an alga that grows there and it acts as a natural biological filter also. Human impacts, you see how it has impacted the corals. Uncontrolled mining for building materials, destructive fishing practices. When they put these Persian nets and other things, everything on the seashore is being dragged, including this. Even fishing with dynamite and cyanides or bleaches. Nowadays, there are many people, they have found a method of catching the fish. Either use dynamiting or sometimes some poisons or even the bleach. More than that, the careless handling of nets, lines, and lobster trap, lobster traps can certainly damage the reefs. Even the anchors from boating also leads to this reef damage. Then the coral reefs are useful for human being in protecting himself or herself from the natural disturbances. If at all there is a hurricanes or tropical storms, that has been stopped by these reefs. Increasing the atmospheric carbon dioxide, that increases the acidity of the ocean. Corals do not prefer highly acidic waters. So this higher oceanic acidity makes it harder for reefs, and as a result they fail to secrete the calcium carbonate skeletons in the higher acidic condition. Even one can talk about coral bleaching that occurs because of the suppression to the growth. We already know that There are zooxanthella living in them. But this zooxanthella lose their color and become white. So that is known as coral bleaching. It can happen in the warmer surface water. And it is estimated that this decrease is linked to the global warming. Even the pollution can be also a cause for coral bleaching. Once the corals get trapped, it takes millions of years at least, or at least decades, you can say. See, this is the one. These are all the same type of the coral, but this coral has bleached. Here you can see the how the corals appear. See here in the second photograph, all the zooxanthella have moved out of it, or they have died. But on this dead skeleton, the algae can grow very easily. Bleaching, you see in this photograph, the bleaching of these coral reefs. Where all you find the coral reef bleaching, you can see the with the red line or red dots indicate that there is severe bleaching. Many times the corals are poisoned also, which has been carried out by the fishing, many those who are in fishing. Even it has been observed that from the boat they spray sodium cyanide, which helps them to catch the fish. The poisons which are either because of the pollution or sometimes the agricultural pesticide also reach the ocean. That kills the corals in the sea. Even there are certain fishes, especially the starfishes, what we call crown of thorn starfish. They kill these corals. The coral reefs are very rich in biodiversity. Healthy reefs houses thousands of species, which include fish, invertebrates, sponges, and they also exhibit symbiotic relationship or mutualism. Every part of this coral is used by one or the other animal, either as a food or for various other purposes. Uh, this is what I wanted to discuss with you as far as the coral reef diversity is concerned. Now, after this, we can move on to another small portion of this coelenterates, that is polymorphism in coelenterates. ಹಲೋ ಕಾಣ್ತಾ ಇದೆ ಅಲ್ಲವಾ ಹಲೋ ಹೇಳಿ ಕಾಣ್ತಾ ಇದೆ ಕೇಳ್ತಾ ಇದೆಯಾ ಎಸ್ ಶ್ರೇಯ ಪೈ ಹೇಳು
Yes, sir. ಕಾಣ್ತಾ ಇದೆ.
okay now I will show under small which may take not more than 10-12 minutes we will finish this coelenterates today. Polymorphism in Coelenterates. What is polymorphism? I have already told you what is polymorphism. Polymorphism is nothing but the existence of different physiological and morphological forms. It is represented by extensive range of variation within a single species. They are all the members of the same species, but they differ physiologically and morphologically. A good polymorphism you can see in the ants, honeybees, termites. All of you, I hope you have observed the ant trails. All those ants in the trail belong to the same species. But see there are some big ants, there are small ants, some are with mandibles, some are with nostrils. So that is what you call the members of the same species appearing either physiologically and morphologically in different forms. That we call it as the polymorphism. The existence of individuals, what you call zooids, of a single species in more than one form and function. In coelenterates, you know, most of the organisms they show minimum two different types. Either they are medusoid forms or polypoid forms. This is what we call polymorphism. See here, polymorphism. This is one. This is the medusae, and this is the sorry, this is the polyp, and this is the medusae. This polyps are sessile forms attached to the ground, but whereas the medusae are free swimming. Why there's a polymorphism? Polymorphism is nothing but the division of labor. It's the diversification of forms and specialization. The function of the polyp is different and the function of the medusae is different. Within the polyp, you have seen many zooids. They are also individuals. Someone is the gonozooid, someone are the uh, dactylozoids. Different zooids are there, and each zooid carry out different functions. It's a cooperation, in other words. So this mostly the polymorphism is seen in the colonial organisms which form the colony. Instead of individual doing all the work, they make groups and they develop cooperation. Finally, the whole colony appears like a single individual. For example, the Obelia colony where you have seen. Obelia is a colony, consists of number of zooids, but it appears like a single individual. So here the individuals or what you call zooids, they function in a group or collectively for the better interest of the colony. So here two forms, polyforms. All of you know they are sedentary or tubular form. In the free end, they have a hypostome, mouth and tentacles. With the help of their aborland, they are fixed to the substratum. Mouth, which is situated on the hypostome, lead to the large cavity coelentron. Many of these polyps may be having a transparent covering, what you call hydrotheca. These polyps are again modified. One is the gastrozoid, which you might have seen in the Obelia colony. These are tubular or sac-like things. Large mouth, which you can see here, and at the base There's a long, hollow tentacles are present. And even the tentacles, they have some side branches, lateral branches called tentilla. These gastrozooids are the feeding zooids. Then you have dactylozooids, which are meant for the protection of the colony. They are tubular. They do not have mouth because they are not going to collect the food. They have a long tentacles which are armed with nematocysts, helps in protection, dactylozooids. Like that, another group, what we call the gonozooids, they are reproductive in function, they are reproductive zooid. Here also mouth and tentacles are absent. The function of the gonozooids is to produce the medusae. Medusae are sexual. By asexual budding, gonozooids produce the sexual medusae. As you see the modification, polymorphism in the polyp, even in medusae also you can see the polymorphism. Nematophores, which you have seen in case of the Portuguese man of war. They are bladder, they are bladders or vesicles which are filled with gas like this. And they are present at the apex of the colony. What is the role of the nematophores? It helps the colony to float. Also help in swimming. Another modification is hydrophilia. They are also popularly known as bracts. They are almost leaf-like structures, having different shapes, leaf-like, helmet shape. These bracts usually cover and protect the other zooids of the colony. They are again different, protective in function. Then Nactocalices. So they are bell-shaped zooids. They have no mouth, no tentacles or sense organs. They have no mouth. Tentacles are there, but there are no sense organs. They are muscular. They are meant for the locomotion of the colony. In the helps in the locomotion of these medusae. So that's why they are popularly called as swimming bells. Then the gonopores. Actually, the gonopores, or basically they are degenerate medusoid forms, but they helps to form bear the gonads. The gonopores may appear as a single entity or in clusters. Even they do not have tentacles, mouth, and sense organs. The function of this gonopore is to bear gonads and produce the gametes. Then coming to the medusoid form, medusae, they are umbrella-shaped structure which all of you have seen with the convex exumbrella surface and ventral subumbrella surface. Usually the subumbrella undersurface, what you subumbrella surface or undersurface, they are provided with mouth and manubrium. So on their body they have a lot of advertisement. Advertisement means don't think of what you get in TV and other things. These are the appendages like radial and circular canals, marginal tentacles, even they are having the gonads, even a frill, what you call velum is present, and they are all free swimming form. In the end, what I would like to say is polyp and medusa are considered as homologous structures which are derived from sac-like body, and they all of them are having manubrium and mouth points to the basic similarity. It has been observed by Hyman in 1940 and published a paper on it. And these two forms alternate with each other in the life history of any typical coelenterate or cnidarian. There's an alternation of generation. They alternate each other. The polyp producing medusa asexually and medusa producing polyp sexually. So this is what has been going on in here. Now the question comes how this polymorphism must have originated. There are one or two theories. One is known as polyorgan theory. This theory has been supported by Huxley et al. Each polymorphic colony is an individual, and either the medusae or polyp which are budded off from it are the organs. They say that there are certain people, they say that each polymorphic colony is one individual, and medusae, polyp, and different types of medusae and polyp, they are the organs. That's what the polyorgan theory says. There is also one more theory, that the polyperson theory, especially the supporter of this theory are Watt and Lucart. This theory suggests that any coelenterate or cnidarian colony is made up of independent and separate individuals which remain in organic connection with one another. What they say is all these zooids are independent and separate individuals, but they are a part of the colony because they remain in organic connection with one another. As I have told you, the zooid is a separate individual where some portion may be either lost or obliterated in the course of time. So, in order to complete their life cycle, they are all joined together and formed a colony. Like that, there is a Medusa theory also that has been proposed by Haeckel and Balfour. According to this theory, the primitive zooids of any polymorphic colony, any primitive zooid, a medusae, which produce other medusae by the process of budding. And these medusae, all of you know that they have the power of locomotion as well as the power of reproduction. Medusae have power of locomotion as well as the power of reproduction. If you accept to this fact, as far as this Medusa theory, many organs of the colony are nothing more than the parts of the medusoid individuals. Again, that goes back to the first theory that we have discussed. Medusoid individuals which have subsequently shifted their attachments from original medusa. So they are all the organs, that's what it says. Whatever, and none of these theories are 100% acceptable. Lot of things are to be said about this. Now the question is, what is the significance of polymorphism? Remember, the polymorphism is very closely associated with the life history. In the monomorphic forms, where there is no polymorphism, say for example Hydra, life cycle is very, very simple. But with the formation of polymorphism, what has happened? The reproductive powers are divided. What do you mean by division of the reproductive power? Polyp is capable of only asexual reproduction, while the medusa is concerned with the sexual reproduction and shows alternation of generation, or what you call metagenesis. The power of reproduction has been divided into two forms. Next one is, it is also polymorphism is also associated with the division of labor. See, the polyps with different types of zooids have the function of feeding, testing, protecting, and even asexual reproduction. Whereas the medusa has concern with sexual reproduction and locomotion. So this is what I wanted to discuss with you as far as the coelenterates are concerned. Uh, with this, we have completed our discussion on the coelenterates. Now, if you have any doubt or if you have not understood anything, please. About this polymorphism and coral reefs, I will give you the send the notes shortly. Any doubt? Another doubt idea? Hello.
No, sir.
Okay, then we will wind up. You may be having the other class. Thank you for attending.